Okay, class, picking up where we left off at, we have the two equations stacked on top of each other after we got the two variables on one side. Now what we have to determine is what variable it is we want to simplify out or eliminate. So what I would suggest is let's do the x's. Since they both have the same sign, we know that we will have to multiply one of these equations by a negative number. Now we look at their coefficient. The common multiple or the least common multiple of 7 and 2 is 14. So we ask ourselves here, 7 times what is 14? We know it's 2. And we ask ourselves here, 2 times what is 14? We know that's 7. And we have to multiply all of the equations by that number. All of their equation by that number. So what we need to do is pick which one of these that we want to be negative. So I would suggest let's do the negative 2. So let's make the 2 negative. So negative 2 times 7x will give a negative 14x. Negative 2 times 2y will give a negative 4y. And negative 2 times 5 will give a negative 10. Now we would take 7 times 2x, which will give us 14x. 7 times 3y will give us a positive 21y. And then 7 times 16 will give us 112. These x's simplify out to 0. Negative 4y plus 21y will give us a positive 17y. And negative 10 plus 112 will give us 102. Now we will divide each side by 17. And y will equal to 6. So now we need to go back to one of these two original equations and substitute in 6 for y. I would suggest let's do the top equation here. So we would take 7x is equal to 5 minus 2 times 6. So 7x is equal to 5 minus 12. So 7x equals negative 7. Then we divide each side by 7. And x is equal to negative 1. So our final answer would be the ordered pair negative 1, 6. And we're done. Okay, now we come to the next problem here. Again, we want to get x or y by itself by eliminating one of the variables. You notice here we're in a perfect situation. We got a positive 3y and a negative 3y. So we can just add these equations together. 5x and 2x is 7x. These 3y's simplify out to 0. Equals 2 plus 12 is 14. Divide each by 7. And x is 2. So now we will go back to the original, one of the original equations here and substitute in 2. I'm going to use the bottom. So we have 2 times 2 minus 3y equals 12. So we have 4 minus 3y equals 12. Subtract 4 on both sides. So we will have negative 3y is equal to 8. We divide each side by negative 3. Y is a negative 8 thirds. So our ordered pair here is 2, negative 8 thirds. Now remember what was stated earlier. If we were doing the method by graphing, it'd be very hard for you to tell that one of the points was a negative 8 thirds. Okay, now scroll down here. Same objective. We need to get an x or y by itself. I suggest that we get rid of the x's here because we know the coefficient of this x is positive 1. So we know our common multiple would be 2. But we'll multiply this bottom by negative 2 because they have the same sign here. And we need them to have opposite signs. So we add 2x plus 5y equals negative 7. Negative 2x plus 6y is equal to negative 4. These x's simplify out to 0. This will give us 11y equals negative 11. Divide each side by 11. And y is negative 1. Now we go back to one of the two original equations, substitute in negative 1. Let's try the top. So we had 2x plus 5 times negative 1 equals negative 7. So we had 2x minus 5 equals negative 7. We add 5 on both sides. 2x is negative 2. Divide each side by 2, and x is negative 1. So our ordered pair is negative 1, negative 1. Now the same directions. Now this time I would suggest we get rid of the y, since we already have the opposite signs, and we know the common coefficient would be 12, a common multiple. So we can multiply this top equation by 4, and we would get 8x minus 12y equals 20. And bring the other equation over. And we would add these together. This would be 13x. These y's will simplify out, and it equals 26. Divide each side by 13, and x is 2. So I'm going to pick the bottom equation and substitute in 2 for x. So 5 times 2 is 10, plus 12y equals 6. Subtract 10 on both sides. We add 12y equals negative 4. Divide each side by 12. And y will end up being a negative 1/3 when you divide numerator and denominator by 4. So it would be 2 negative 1/3. That's the final answer. Now we solve this problem here. Again, I will get rid of the y's. Common multiple of both of these will be 15. Need to multiply the top by 3 and the bottom by 5. 3 times 3 is 9x. 3 times 5y is 15y. And 3 times negative 9 is negative 27. 5 times 2x is 10x. 5 times a negative 3y is a negative 15y. And 5 times 13 is 65. And we would add these two equations together. 19x. These y's simplify out to 0. Negative 27 plus 65 will give a positive 38. We divide each side by 19, and x is 2. So I picked the top equation this time to substitute in 2 for x. So 3 times 2 is 6, plus 5y equals negative 9. Subtract 6 on both sides. 5y equals negative 15. Divide each side by 5. And y is negative 3. So we add 2, negative 3. That's our final answer here. Now, scroll on to the next page. It says linear systems having no solution or infinitely many solutions. A system of linear equations and two variables represents a pair of lines. The lines either intersect at one point, are parallel, or identical. Therefore, there are three possibilities for the number of solutions to a system of two linear equations. The number of solutions to a system of two linear equations. The number of solutions to a system of two linear equations and two variables is given by one of the following. Exactly one ordered pair solution and two lines intersect at one point. No solution and two lines are parallel. Infinitely many solutions and two lines are identical. If you look here, one solution, parallel these lines will never touch, so it's no solution. And infinitely many, if you see here, you had a blue and red line right on top of each other. Or I should say burgundy line. So it connects at every point. Now, what if the equations don't intersect at exactly one point? The lines are parallel, there are no solutions. If the lines are the same, there are infinite solutions, with the solutions being the solutions to either equations. The above information can be summarized in this table. And we saw that earlier. Okay, it says solve the system. Doesn't matter which method we use. I'm going to use the elimination or addition method. So I'm going to get rid of the x's. We know we have to multiply one of these by a negative. And the common multiple of 4 and 6 is 12. So I do negative 3 here and 2 here. So this will get negative 12x minus 18y equals negative 36. This will give 12x plus 18y is equal to 24. All of these simplify out to 0, and it equals to negative 36 plus 24 is a negative 12. Now, whenever you get a solution of a number equal to another number, and they're not the same number, and that means they're parallel lines, so it's no solution. Again, if you end up with two numbers, no variables, and they do not equal each other, the answer is no solution. Now we come here. This time again, I'm going to do the addition method. Let's get rid of the x's. We just need to multiply the top equation by negative 1, or you could have did the bottom by negative 1. The negative x minus y equals negative 1. We bring down the second equation here. These simplify out. Negative y plus 2y will give us y. And negative 1 and 0 is negative 1. So now we go back and substitute in negative 1 for y. I choose the top equation. So we add x plus negative 1, be x minus 1 equals 1. Add 1 on both sides, and x is 2. So we add 2, negative 1. Now we come here. This time I'm going to use the substitution method just to switch it up a little bit. So what I'm going to do, I'm going to use this top equation. I'm going to go up here. So I add 3x to both sides. So you add y is equal to 3x minus 2. So now we're going to take this answer here. We're going to substitute it into the second equation. So we have negative 6x plus 2 times 3x minus 2 is equal to 4. So we have negative 6x, 2 times 3x is a positive 6x, 2 times a minus 2 is minus 4 equals 4. Now if you notice here, a minus 6x and positive 6x simplify out to 0. Minus 4 will be negative 4 equals 4. You notice here we have no variables, and these two numbers do not equal each other, so it's no solution. So now we scroll to the next number here, or the next example. So again, this time I'm going to go back to using the addition method. I want to get rid of the y's. So I just multiply the top equation by negative 2. And this will give us negative 2x minus 4y is equal to negative 4. Bring down our 2x plus 4y equals 4. We'll have 0 here. Negative 4 plus 4 is 0. Whenever you have two numbers that are equal to each other and no variables, the answer is infinitely many solutions. That means every order pair that works in the first works in the second. Okay, now come down here. The next example. This time I'll get rid of the y's. Multiply the top by 2. This will be 6x minus 4y equals 14. Negative 6x plus 4y equals 5. 6x and the 4y simplify out to 0. 14 plus 5 is 19. They do not equal, so it's no solution. Because those lines are parallel. Here we can use the substitution method since it's set up already.